And welcome back. Today's question is one of those questions that I like to ask as an interview question because, well, it allows you to sort of think through the question and talk through different ideas, and the answer falls out eventually. However, of course, you don't have me talking to you as you try and do the question. So I'm going to give you a slight, it's not a hint, but I'm going to reword the question slightly. You can think about the question as how many zeros are there at the end of 1,000 factorial? Either way, pause the video, have a go, come back, and let's see if we've got the right answer. All right, so how do we think about these sorts of questions? Well, because you're clearly not going to work out 1,000 factorial, it's so large, you must be thinking about building up slowly and think about what numbers fall out. So the first thing I would do is just write down the obvious thing. So 1,000 factorial is 1 times 2 times 3 times 4, etc., up to 1,000. Great. Within that, well, again, oversimplistically, but it's worthwhile thinking how to build this question up. I've got a 10, I've got 100, and I've got 1,000. So that gives me 6 zeros. So clearly incorrectly, but allows for a bit of discussion in an interview situation. Well, that tells me that that's 10 to the power of 6. So is that my answer? And hopefully at this stage, all of you are saying no. And again, when I'm doing this as an interview question, the next question is why, and of course that's because I can do 5 times 2, which could be another 0, or 25 times 4, which gives me another 2 zeros, and etc, etc, etc. So I need a more systematic way of thinking about what I'm doing here. So that's definitely not correct. What I do notice is when I'm looking at prime factors, I'm looking for pairs of 2s and 5 that I can combine. So in other words, I'm looking for multiples of 5 and 2 when I'm looking at my prime factors. Moreover, I can rewrite the whole question as how many unique pairs of 2 and 5 can I create? So again, let's go back to first principles. So my factorial can be written as 1 times 2 times 3, etc. And if I break that down into prime factors, well, that's going to give me 1 times 2 times 3 times 2 times 2 instead of 4, and times 2 times 3 instead of 6. And what falls out really clearly is I have a lot of 2s. 2s are not my issue here. So ultimately, I'm thinking about how many 5s I can get from the prime factors of the numbers up to 1,000. So I now can rewrite my question in a way which is much more helpful. I can rewrite my initial question as when 1,000 factorial is written as prime factors, how many 5s are there? And this I can do systematically because I know every fifth number is going to be a 5. So it's definitely the case that 1,000 divided by 5 is 200. But the problem I've got is 25 is 5 squared. So I've counted the initial 5, but I need the second 5 as well. Well, because 25 occurs every 25th number, I need to divide 1,000 by 25, which is going to give me another 45s. And you can probably guess where I'm going next. 125 is 5 cubed. There's going to be 8 of those up to 1,000. And 625 is 5 to the power of 4. And so 1,000 divided by 625, well, there's one of those that I care about. Count all these numbers up, and I get a total of 249. In other words, to answer the initial question, 10 to the power of 249 divides exactly into 1,000 factorial. And that's today's question done. Well done if you got that. We tend to get to the answer when we do this in interview mode most of the time. Sometimes people need a bit of prompting, but if you got there by yourself, well done. Usual thing, like and subscribe, please, and I'll see you for tomorrow's question. Thanks all.